Hey, this is Matt. Today I want to talk a little bit about GFA and FAR calculations within CityEngine, since those types of calculations are quite important for architecture, urban design, and so on and so on. So there's a couple of different cases I want to talk about. So there's the shape cases. So for example, I have a parcel shape on which I start. And so basically on a given parcel. Or I just have a footprint shape and either no parcel shape or an imaginary one, or I just have to draw it otherwise to be able to inform my building with the actual parcel area. So we're also going to have a look at this example. Then the other cases here, I named them A and B, are basically whether I'm interested in actually calculating the FAR and GFA values based on a given building height and basically based on a given geometry. And then the case B is where I'm actually interested in reach a certain FAR or GFA value. That means that, for example, if the footprint changes and I want to reach a specific GFA or let's say FAR value of 2.8, that the number of stories adapts accordingly. And so that would leave me the option to basically design a footprint and have the building height be adjusted to always go for a specific FAR value. And that is also possible. So let's go ahead and get started with a clean project. So here I have a project which is called FAR. It's still empty, so I'm going to create a new scene. And I'm going just to name it calculations. Like so. Okay. I'm not going to choose a coordinate system. Okay, so after the scene has been loaded, I'm going to start with the first case. So I have a parcel shape. That's maybe the easiest shape. So I'm going to zoom out a little bit. We see here the grid size is 10 units, so I'm gonna zoom out about like here. Now I'm using the polygonal shape creation tool, and I'm going to draw something which is looking like a parcel, something like this. Very good. Okay, now let's double selecting this edge, and additionally I'm selecting this edge with the shift key. And now, since these are this is a static shape, I'm going to shapes and I'm going to set this as a street edge. So for those not familiar with what that is, I'd recommend to go on the forum, on the CityEngine forum, and check out the tutorial 1 and 2 videos. Okay, so now we informed that shape, that street width 2 and 3, so basically edge number 2 and 3 have a street width of 1. So I'm just going to leave this. I'm going to hit DG to hide the grid. Okay, so that's our little parcel shape on which we want to start coding. So I'm going ahead and I'm creating a new rule here. And the first, which I'm going to do, parceling, and change to the text version. Okay. So let me first go in and just create a few attributes for the parceling. So I'm just going to make this a very, very simple example. So we will have, let's say, front setback, which is, let's say, 10 meters. Then we have a back setback with 5 meters, and we have a side setback with, let's say, 3 meters. Okay, so let's first go ahead and create a start rule, which is called Parcel. Okay. Now, the first thing is, since we are starting at the parcel shape, and I want to go ahead and cut this up a little bit so we wind up with a building footprint on it, I have to go in and cut the geometry back. So for this, since I'm using these attribute names here, I think it's best to make it very, very simple and just use the setback operation. So let's quickly go to the help and go check out the documentation. Let's go CGA file reference, rule reference, and go down here to, where are you, setback here. So we see we have different selectors which are possible. So that's the synopsis. So we have the setback with the distance, and then the selector, and selector 1 for the first shape, selector 2 for the second shape. So that's pretty easy. If you want to learn a little bit more about how to write CGA code, I would recommend you go to the tutorial 6 video, which is also mentioned in the FAQ thread in the general discussion on the CityEngine forum. It's a sticky thread. Okay, so let's write set b and then control space, and there is the command completion. So I'm going to use this here. Now, setback distance, I'm going to choose front. So that's the first distance of the first cut I want to make. Then I say street.front, and that will give me nil. I'm not interested in the shape, so I'm going to delete the geometry with nil. Nil. The remainder, this here, that's basically the rest of the shape. So I want to actually go and keep this. So I'm just putting in just a standard shape name, just X, and go ahead and for the first time assign the rule. So you see that the start rule was automatically assigned. That's cool. Oh, don't move it. Undo. Save the scene, save the rule file, and generate. Now we see there's the street edges. Let me actually check this out. This is the first edge. This is street.front. Okay, yeah, let's just continue. No problem. Let's hide the shape. Yeah. Okay, so we have two street edges here, and we see that there is the setback going on to the back of the first edge. So it seems that in this specific case we have the street.front, which is oriented on the front. So yeah, let's just continue. Now let's actually duplicate the same thing here and cut away the back. So I'm going to go and use back setback and street.back, and go ahead and do the same thing again with the side. So street.side, and use the side setback. Remainder, let's put this, give this a name, and name this footprint. Save, generate. There's a little error, remainder gives brackets 2, 3. Save, that's better, and generate. Now what we see here is we cut away from the front. This is this distance, the 10. Then the rest is from the back. This is 5, and then the last is the side setback, so from the side. So let's just make a footprint which is a little bit more realistic. So let's move this over a bit and make these dimensions quite a lot bigger. So let's go to 15. Cut this back quite drastically. And the same for the back. And also for the side. Yeah, let's say this is okay. It's just an example. Okay. Now we have, we started at the parcel shape and we have done some very simple parceling. So this is our building footprint. Okay. So let's go ahead and continue with the footprint. Now on the footprint, obviously, we want to have something like world.y and then let's say 20 meters, and this gives my building volume. We want to have something in this direction where we can actually see the building as a 3D geometry which we can calculate. Or since we are interested in the specific statistical values, we will be interested in something like this. So let's go in and add some more attributes. So we will write an attribute called, let's say, building height. Building height, which is going to be 30 meters. We say ground floor height, which is, let's say, 5.5 meters, and upper floor height, which has usually a standard of about, let's say, 3.5 meters, like, for example, should do fine. Okay, so let's go in and link the attribute here. Paste, save, generate, and we see the building just got a little bit higher. Okay. So let's quickly continue with a series of splits. To split this volume into sub-volumes. So the first thing, since it appears only once, we want to cut away the ground floor. So I'm going to use the ground floor height as an absolute value, so an absolute distance, and say this will produce a volume, and I'm just passing on a parameter here, and I name this the parameter as I just pass along a string, and I say this is a GF, this is a ground floor volume. Now the rest, so that would be basically approximately 1. This is basically the rest of the volumes, so this is upper floors. Just naming this accordingly. Obviously, this upper floors volume here, I want to where is it? Higher. I want to split again, so I'm just copying this line here and pasting it in here and change some of the code. So I know this is a repetitive split, and I'm going to use approximately the upper floor height. Oh, wrong syntax, like so. Okay, let's go and zoom in a little bit on this model and generate it again. Yeah, works. Okay, so we see the volume has been split in a lower part and a specific sequence or a specific number of upper floors. Now, why is this exactly giving a full number of floors? Because we are using this star sign, star character, together with the tilde sign, which evens out the and rounds basically the number of produced splits. Okay, so this volume here, I'm making another rule for this, and I'm naming the incoming parameters. So that would be something like volume type. And say now case, in case this volume type is a ground floor. In that case, I'm going to colorize it red, so RGB. Else, in case that it's not a GF, so in let's actually fix this. In this case here, I want to go ahead and create 0, 1, 0, basically green. Okay, so let's regenerate the model again, and we see that this actually produces the correct geometries, or the correct geometries and the correct colors. Perfect. Okay, so what are we doing now? Let's quickly go ahead and write a rule which does some reporting. So I'm going to write here reporting to call the rule for the reporting. I do the same here and here. So this rule here is basically just used to colorize the volumes. And then I'm going back to reporting, and here I don't need the information of the volume type anymore, so I'm just going to continue. And in here, now here it gets interesting. So here we are going to actually call the reports operation. So we have the key, let's say GFA, and the value. Now, let's quickly go back into the CityEngine help. And let's go to geometry.area. Let's find this. Where are you? Here. Geometry.area. Now, there's a distinction between area and area with specific selector, the area selector. So when I'm writing this here, geometry.area, then the whole shape surface is returned. But I'm not really interested in this, since I'm having a volume. So the surface of the whole volume is not the number I'm interested in, because I just want the bottom face area. So I'm going to use the selector to actually choose just to calculate the bottom area. So I'm interested in this here. Now, this is all relative to the scope, so make sure the scope is vertically oriented, so upside down, or not upside down, but really vertically oriented. And it is, since we have just extruded vertically up, so yeah. Okay, I'm going to choose bottom, close the help again, and put that in here. Geometry.area with the selector bottom. Now, this is the GFA. Let's copy this and go to the FAR value. Now here it gets a little bit more complicated, because we have to somehow know what the parcel area is. So I have to know that attribute name here, or that value. and I did not create that attribute yet, so I'm going to make a little bit more room here and write at hidden attribute parcel area. Now hidden means that it's not showing up in the GUI or in the inspector. So if I select this here, you see there's a parcel area does not show up here. Okay, that's good. So I'm actually using this just behind the scenes basically. And I'm initializing the attribute with a standard value of 0. So I'm copying this, and right at the very beginning of the parcel rule, I'm going to override this value with geometry dot area. And here I'm using the full area of the polygon. So that means that the area of the shape here is calculated and put or set in instead of 0. So that's the very first thing which I'm doing, and this is quite important. So now there may be one question is why do you calculate the FAR value like this? Why do you use this specific function here, or this mathematical way? Because usually what you want to do is you first want to sum up all the areas, so basically calculating first the GFA, like so, and then divide this by the parcel area. Now, it's a little bit tricky to explain, but it has to do with the model hierarchy. So let's quickly go in here, enter the so-called inspect model mode, and then go to the model hierarchy. Now here you see all the shapes which were produced. We have the reporting actually continues here, and then it comes back. Let's show all. Okay, perfect. Okay, now we see here that from the footprint we go to the volume, we have the upper floor, and then we basically produce a series of volumes. Now there's a certain limitation in CityEngine, is that once shapes have been split, so for example the upper floor's volume has been split into subvolumes, all of these subvolumes don't know anymore of the existence of the others, of the other volumes of the same type, basically. So you see that the information can always just flow downstream, basically down the model hierarchy or down the tree here. But you cannot go and query information back from, so basically go up into other branches and collect information there. That's just a current limitation of CGA. And to actually bypass this, it's very easy just to report the ratio, or the ratio of the parcel area for this specific single volume, and the whole thing itself then gets summed up. So in the end the reports will be the same. Okay, so here we have done the reporting. Now after the reporting I personally usually nil the geometry, so I'm not going to continue here. Now you will see when I generate you've seen it already, the geometry disappears, but that's okay, because I'm going to make a copy of the volume, and I'm going to call this visualization, and that's also something which another forum user has made, and I'm just using this as another example. So we can also go in and now say, for example, let's move that up here. add the viz mode, lay out this a little bit nicely, and let's say at range we have the types of transparent. Could we do as is, and top and side. Okay, let's make this the default here, as is. Okay, let's go down here. Case viz mode equals as is. Then we know we are done. As is. Then we have transparent, and we have top and side. Actually, let's make just the else case here. Okay. So in the transparent, we want to make the stuff actually transparent. Set material dot opacity 0.3, for example. And in the last case here, we want to make a component split of all the faces, and we say top is top. And side gives side, and the rest, let's just for completeness sake, all of the rest is nil. Okay, generate again. We see the default is as is. We also see some flickering of the geometry because there are duplicate shapes on top of each other. So what I could do is, no, I'm just going to leave this alone for now. So I'm going to change to transparent or to as is. I'm still in the inspect model mode, so that's why it was still transparent. Now that's transparent and top and side. Okay, so that's basically the last rule here. The visualization, that itself is just the visualization of the geometry. And now, since we have written the code like this, basically completely independent of any reporting of the geometries. So that's cool. Okay, now let's quickly open up here and let's add another report here. Report. And let's name this Parcel area and use the attribute Parcel area here. Regenerate the model and open the reports tab. Now, what do we see here? We see we have 3 reports. Perfect. So there's a... that's wrong. That's actually in the wrong position because this is called too many times. This should be reported only once here. Yeah. Now we see it just got fixed. So we have one number, or that's the number, one report of the type parcel area, and we see the sum, or basically the area is 17,200 square meters, and the GFA is divided among 8 floors is 2,370, so that's guesstimated that's about a tenth. So we see the FAR value is correctly 0.14. So since we are that's what I explained before quickly concerning how we have to report the FAR value like this. Here, why is the information in the sum tab of the reports? Because the sum is basically summing up all these ratios between the GFA part or the section or the part of the full GFA value divided by the parcel area. So this is actually summed up to the correct number of 0.14. Okay, so that's the way of very simply calculating the FAR value based on a given parcel shape. So now, since everything is actually set up, of course I can go in and play with the values. So that building here, you see that directly the reports are updating. And I can also go in and change, for example, the height, obviously the building height, and make it much higher. And we can play and fiddle with this, for example, until the FAR value is exactly 1. So basically, the parcel area is equal to the GFA value. Cool. Very nice. Let's make this transparent. Transparent. Perfect. Looking good. Okay, let's save the scene at this point. Let's go back to the to this little yellow list. So that was case 1. I have started with a parcel shape. Now, the same thing I could be interested in if I have just a footprint shape. So let's quickly go back and create a footprint shape. I'm going to make a rectangular footprint like so. I'm going to assign the same rule, parceling. It's actually a bad name now meanwhile, but let's just go ahead and ignore this and choose the other start rule, which is called footprint. So let's, just for completeness sake, also add this here to the footprint. Now, we see here we can already generate the building with the default values, and we also see that the GFA is calculated correctly, but the FAR value is 0. And why is this? Obviously because we skipped basically the part where the parcel area could be defined correctly, obviously because we don't have a parcel area. So let's move this a little bit aside and talk quickly about let's make a parcel for this guy so that he's not lonely. Okay, so here's another parcel shape. Yeah, okay. Now in CityEngine sadly there is no direct option to calculate the area of a shape directly within the GUI, so I have to create another quick rule. So I'm going to add a new rule, and then I'm going to say calc area, finish. And I'm going to say plot, no, I'm going to say parcel, print geometry.area. I'm going to open the console quickly to see the printout and assign the rule. Calc area, generate, and in the console we see the area. So that's about complicated number, let's put it like this. Okay, 133,000 square meters. Let's go in and for now create an object attribute. Doesn't work here. Ooh. That's a bug, that's not good. Huh. Okay, I went in and fixed the problem. I just created my object attribute by using Python. Okay, we have now the object attribute, so let's go and see how we can access this this object attribute from this geometry, sampling this geometry from our main building shape. So let's select this and use this little button here where it says in the parcel area attribute, and this opens the connection editor. Now since we are sampling, we have to use layers. We are using the meshes layer, and in there's a parcel area object attribute which is found. This is actually the other shape. So I'm going to use OK. Now you see that the 133,000, that's actually the correct value which is linked from the layer called meshes. You see the text is written in italic, so this value is let's say inherited. Okay, cool. So let's go ahead and generate the model again, and the value 0.22, that did not change. So let's quickly test whether this really works. So I'm moving the shape out, and at some point where there is no more information, since we are no more in the shape, you see that here it drops to 0 because there is no information available of that object attribute. In, out, perfect. So that actually works. Cool. So now whenever I wanted, for example, to edit this shape here, I would have to go in and actually update this value also here. So that's not absolutely interactive because object attributes cannot be set directly with CGA. So for this you would have to maybe use a Python script to keep this stuff up to date. But anyway, that's how it is. So let's go quickly back to the list. Okay, I have now shown case 1 and case 2. So we have calculated the FAR and the GFA values based on a parcel shape, and we have created it based on a footprint shape by informing the footprint what the metadata is basically of the other parcel shape, which is not really connected to the actual geometry. So we established that connection by using sampling. Or of course you have the option by just using the this value hard-coded by entering the value here. But let's not do that right now. Okay, so that's actually all we did so far, is calculating FAR and GFA values. Now, that's basically taking the statistics, calculating the statistics based on a given geometry. So based on a given building height, based on the calculated or based on the resulting number of floors, and this is basically updated all the time whenever I change anything in the system. I have now, so number of floors updating, GFA updating, and so on and so on. So now let's look at the last case here. This is case B, so that's the reach scenario. So how can I reach a specific FAR value or a specific GFA value? Okay, let's go back and add some more code. Again, we have the, what should I say? We have still the same scenario, so we are working on a footprint. We still have parcel area, but one thing is fixed, and this thing which is fixed is another attribute which I'm going to name target FAR, for example. You can do this with FAR, you can do this with GFA. I'm just going to use the attribute name FAR right now. It's actually a very small distinction in the two cases. So let's go in and write down that code. So let's say the target FAR value is 2.6. So that's the GFA has to be exactly, or plus or minus exactly the same as 2.6 times the parcel area. So let's go in and continue with that information. Okay, so the first thing is we will be starting at footprint. So that's footprint. Let's actually rename this here footprint. Let's name this footprint calculate, as we have had it just before, and let's add a new rule named footprint reach. So that's just going basically another way. And actually I'm using the other examples. I'm just changing this here, so I'm going back to the fully dynamic example over here. Okay, perfect. So we are still using the same parceling code, but then branch off to the reach calculation. So let's go down here and make a little comment line here so to see this is something different. Okay, so footprint reach, what are we doing here? So one way to actually solve this issue is, and I use this quite often, is to use a so-called recursion, which is basically a rule which calls itself until a certain breakout criteria is met, or breakout statement. So let's call a recursion. Let's name this guy reach recursion and pass on a parameter. Now I'm going to say target FAR value multiplied by parcel area. Now what is this? So what I'm passing on here is the target FAR value 2.6 multiplied by the parcel area. So if we make this multiplication, so the value of this multiplication is actually the GFA value I want to reach. So I'm going to build as many floors until this is met. And let's copy this. Let's continue. Let's make this nice. Oh, not too much. Let's name this rest area. Rest area meaning the rest to be built, or to be met basically. So we can say case rest area is bigger. How do we do this? Yeah, let's make the distinction with the actual footprint. No, not this here. Geometry.area. Let's make the statement like this. If the rest area is smaller than the actual area of the incoming shape of the footprint, then say done. Do not continue if the rest is smaller than one floor shape. Else, if the rest is bigger than one floor to build, actually build the floor. That means extrude the shape. So by the way, I'm going here into here always with a 2D flat shape. So that's not an extruded shape. That's really, really important to know. So that's a 2D flat shape equal a floor footprint. So that's a flat shape. Okay, then I'm going to, at this point here, I'm going to extrude the shape. So world.y, and then I am extruding it let's make that distinction. Let's do this. Shall we really? Yeah, let's do this just to show what can be done really with CityEngine. So we have a floor hidden attribute called current floor index. So we start with the current floor index, which is 1, first floor. Then we make a function which defines the height of the extrusion based on the floor index. So floor height function equals case current floor index equals 1. Then choose the where are you? Ground floor height. Ground floor height, else use the upper floor height. Upper floor height. Perfect. Okay. I just went in and fixed the line here, so that's I just changed the position of this set here to make this actually work, because it's a little bit difficult, or setting the actual value of the current floor index has to be set at the right time for this to work. So I just tried to figure this out quickly. Okay, so the first extrude will be with the ground floor height, and from then on we are using the upper floor height for the extrusions. Now, as you see here, we are always just extruding one floor at a time. Now, after the first floor, we have to somehow continue. So what we are doing here is we are actually splitting off two shapes, basically. So one floor will continue with the recursion, building other floors, and the second shape will be the actual floor. So what we are doing here is we will go directly to the reporting. I'm not gonna go into the volume specification here. I could do, but this makes the code a little bit too complicated here for now. So let's just go in and pass this on to the reporting. And then we are going to wrong here, make a duplicate of the shape. So this is a valid rule, and now we are, so reporting is called here, and here we make a duplicate of the shape directly. So we will be continuing with the top shape. Obviously the rest of the shapes of the duplicate of the volume we are nilling. So here what we are going to do is we are going to just call the recursion again, but not with the same input area, but we are taking away, or we are subtracting geometry geometry.area. So here we are actually using the value which is incoming, and then we are just subtracting one floor and going back into the recursion. So let's save this and let's generate. Aha, perfect. Let's actually see why we don't have any geometry. Obviously it's because we just stepped the visualization part here, or we skipped the visualization part, but that's not too that's not too bad. So let's actually go in and fix this. Visualization reach, pass on the let's copy this out here, current floor index, let's put this here. ID, case ID equals 1, then volume GF, else volume UF. Where is the error? There is one error somewhere. Visualization reach. That's tricky to find. Here. Save. Okay. Generate again. Now we have just remapped the current floor index to the string of the actual volume. So here we have the visualization again. And now you see that we have a much higher building here. This building actually represents now 2.62 of the FAR value, and here we could here you see that the target is exactly 2.6, but what we reach is actually not precisely 2.6, so this could be a little bit below or a little bit above 2.6, because we are always creating a full number of floors. So the correct height would be, for example, 17.85 floors, but sadly that's not buildable. Okay, and now let's go in and play with this reaching. So let me move that here and go in. So the setup which we have now is actually really cool. So we can just play with the parceling rule, front setback, make this bigger, smaller, and also play with the side setback, and you see how the actual building grows higher and higher to reach that specific GFA or FAR value. Ooh, there's upper floor height, that's okay. So let's reset all attributes back to the defaults. Okay, so that's it also for the last point here, the reach FAR and GFA case. Now, the code here obviously got a little bit more complicated, and I was improvising the code now on the fly. So there are certainly ways to code this different, especially the part here with the visualization reach and setting the floor index, just to be able to have still the distinction between the ground floor height and the upper floor height, but still get the full FAR and GFA calculation. So all that stuff here, you could all these hacks here, you can cut them out in your code if you just have unique floor heights for both ground floor and upper floor heights. That's it for the video, and I hope you learned something, and put some comments below on the video if you want to have videos on other specific topics concerning CGA and CityEngine in general. Okay, thanks, that's it, bye bye.